we have the limit of 1 over x plus 2 as x goes to -2. So I graphed it in the calculator, and I want to handle the left side and the right side one at a time, because in the subsequent problems that we have, some of them do say find just one side limit or the other side. So let's take the limit coming from -2 on the left. So going toward -2 from the left, coming this way, you see that the y values are dropping, and then they start dropping very fast. So we do a second calc value, put in something very close to -2 but to the left, -2.001. Second calc value comes out -1000. So as you can see, as we're approaching this vertical asymptote, from the left, the y values are dropping very large negative. So in that case, we say that the limit is equal to -infinity. Technically, it does not exist, but it does not exist in a very special way. So we're allowed to put -infinity to indicate that the values are not just undefined, they're undefined in a way of getting very large negative. So that tells us something about the function. Then we go on to coming from the right of -2, going this way, and you can see that the y values are getting bigger quick as we approach into -2 from the right. And if you put in -1.999, which is just barely to the right of -2, and do a second calc value, you get 1000. So when you're almost there, you're getting a very large positive value. So we're able to say that this limit, as x approaches 2 from the right, is going to be positive infinity. Even though, just like the other one, it actually does not exist, we're able to say positive infinity because the y values are getting very large positive, and that tells us something about the function. So the final answer to the original problem is that this limit does not exist because the left-hand limit doesn't equal the right, and it does not exist. You can talk about left-hand limits or right-hand limits, each of which do not exist technically, but we would be able to say -infinity, positive infinity. But for the original problem, it just does not exist.